In this segment, we will talk about how we can estimate the second derivative of a function which is given at discrete data points. So if we are given, let's suppose x naught, y naught, x1, y1, all the way up to x and yn. So let's suppose we're given n plus 1 data points. And if they're not given in ascending order of x, you can put them in that particular fashion. So we are assuming that this data set which is given to us is in ascending order of x values. And so what we want to do is we want to be able to find out what the value of the second derivative of a function will be at a particular point. So then the second derivative is approximately given by the value of the function at x of I plus 1 minus 2, the value of the function at x of I plus the value of the function at x of I minus 1 divided by the difference between let's suppose x of I plus 1 and x of I whole square. Now keep in mind that this is the same formula which we use for the second derivative of a function of a continuous function. But you got to understand that when we are finding the second derivative of a continuous function, the value of the function is given at all the points which we need in order to find the second derivative. So what is the difference is that now, since the value of the function is given at discrete data points, you have to have the value of the function at this point, and the point where you are trying to find the second derivative. Those have to be available to you. Also, what you got to have is that the difference between the point ahead with the point where you are looking for the second derivative and the difference between the point where you're looking for the second derivative and the point behind it, that distance has to be the same. Only then we can apply this particular central divide difference formula to find the second derivative of a function. Let's look at an example, and I think some of the things which I mentioned here will be clear when we look at those examples. Look at the example. So here is a upward velocity of a rocket which is given, and you are given the velocity. So v of t is given, and you want to find the jerk of the rocket. So jerk of the rocket is given as the first derivative of the acceleration, which will be, of course, then the second derivative of the velocity. So if we want to find the jerk of this rocket at 15 seconds, that means we have to find the second derivative of the velocity. And it is asked that, hey, we find this jerk at 15 seconds. If that is the case, now first we are given these data points in ascending order, so we don't need to sort them out. And then let's see, now we have 15 is where we want to find the jerk. And so what we have to figure out is that, hey, do we have a point behind and a point ahead, which we do. 10 and 15, 10 is a point behind and 20 is in front of it. But then we also have to see that whether the distance between the 2 points here is same as the distance between these 2 points, which it does seem to be the same, because 15 minus 10 is 5 and 20 minus 15 is 5. So having said that, let's go and see that how we can find the jerk at 15 seconds. So the jerk at 15 seconds will be equal to, so based on the formula which we have, will be the velocity at 15 plus 5. So this is your x of I plus 1 or t of I plus 1 minus 2 times the velocity at the point where we are seeking to find the jerk, plus v at 15 minus 5, which is the point at the point behind. So now here we have what is the difference between 20 minus 15 square, because that is the difference between the two. And here we'll have velocity at 20 minus 2 times the velocity at 15 plus the velocity at 10 divided by 5 squared. So what do we get from here? Velocity at 20 is 517.35 minus 2 times the velocity at 15 is 362.78 plus the velocity at 10 is 227.04, and we divide it by 5 squared. So having said that, all we have to do is to do these calculations and be able to find out what the velocity is. So in this, what the jerk is. So in this case, it turns out to be 0.7532 meters per second cube, because it is the first derivative of acceleration with respect to time. So the units are meter per second cube. And that is the end of this segment.